Ladies and gentlemen, we're looking at Stretching and Shrinking 4.2, and we're going to be looking at triangles this time. So we can identify similar triangles using side lengths and angles. That's our I can statement. For the first one, I just want you to look at these two. We were able to, with rectangles, showing that they're similar using scale factors, but also we were able to do that using corresponding sides within each shape and making them into ratios. That's what we did with 4.1. Looking at this, what I'm going to do is I'm going to set up, and I want you to do the same, I'm going to set up ratios for each one of these triangles. And it's going to be 7.3 over 9, so short to the middle length, and then short to the long length, 7.3 over 12.5. And I want you to set that up to the right of each triangle. Do that right now. I'll do the same. All right, now that these ratios are set up, let's just look at the angles first. We have 45 and 35. Our missing angle right here, if we add that up and then subtract that from 180, we have a missing angle of 100. Over here we have 42, 58, 145, so that missing angle is 35. 145, this missing angle is 35. So just looking at the angles, we can figure out that triangle B is not going to be similar. The rest have the potential. A, C, and D have the potential. Now what I want us to do is take our calculators out, and I want us to divide each of these ratios to figure out which one of them, to figure out the ratios to see which one of them are the same and which one of them are not. If they are all the same, or at least comparing short to middle and short to long, then we should be okay and figure out which one of these are similar. So let's do that. Write it right underneath, possibly in a different color. One other thing, as you're writing it, as you're dividing 7.3 divided by 9, I want you to round to the nearest hundredth. Round to the nearest hundredth. These are going to be approximate measurements. All right, as I divide these out, I got approximately, that's what the squiggly equal sign means, approximately 0.81 and 0.58. 0.81 and 0.58 for D, for C, 0.81, 0.58 for D, but look at B. That was the one that we already determined was not similar, but with these ratios, we also see that it's not similar. About 0.79 and about 0.68. The rest of them, they're not exact. These are approximate, and that's what I don't like about this book, that they didn't make them exact. But these are approximate side lengths, and they got us close to the ratios for each one. All right, so down here, we did B1 by writing these in. How do the ratios of the side lengths compare for the similar triangles? They are exactly the same. And number 3, how do the ratios of the side lengths compare for triangles that are not similar? They are different. They are not the same as the ones that are similar. All right, for this one, I want you to do the same. List all the pair of similar triangles. So if you didn't understand that process, I want you to go back, watch the first one that we did on the last page. But right now, I want you to write the ratios for short to middle, and then short to long, but also pay attention to the degrees. 30, 94, 56, 94. You're going to have to find out that missing angle. So again, add them up and subtract them from 180. Find out that missing angle. But then look over here. I mean, 120 and 44, that doesn't share any of the angle measurements. So I'm going to tell you right now that angle E, you don't have to do anything with that. You can cross that out right now. But otherwise, tell me which triangles are similar, and I need you to show the ratios for each one. All right, that's it for today. A very short lesson. Got in within 5 minutes. If you have any questions, please make sure to write them down. But remember, for triangles, we are going to find similar triangles using side lengths and angles. We have to use both. We can't just use one or the other. Have a great night, everybody.